Okay, exercise 14G on inclined planes. We're going to do example 31. It's here in the Cambridge textbook. So we read, a particle of mass 5 kilos lies on a smooth plane, inclined at 30 degrees to the horizontal. There is a force of 15 newtons acting up the plane. Find the acceleration of the particle down the incline and the reaction force. So, setting this up, I've got an incline, 30 degrees is my angle. I have three forces. I have my 15 newtons acting up the plane. I have my reactive force, which is perpendicular to the plane. And then I've got the weight coming down, which is 5g, because we were told that we had a mass of 5 kilos. So 5 times gravity, remembering g is 9.8. Just pertinent notes, so it's a smooth plane, so there's no friction. So that's why in the I direction here, or on the plane, we only have the 15 newtons acting up the plane, no friction against it. 30 inclined, 5 mass, and the force up the plane. Now I'm going to set up that my I direction is parallel to the plane and my J direction is perpendicular to the plane. We are asked to find two things, the acceleration and that reactive force. So what we're going to do, sorry about that for the walls. So we're going to look at our forces in both the I direction and the J direction. Let's look at our three forces to start with. Now I'm going to label them force 1, force 2, force 3. Force 1 is the 15 newtons up the plane. So it's 15I, 0J. I've designated that up the plane is positive, so down the plane will be negative, and then up perpendicular from the plane in the R direction will be positive, and coming the opposite way will be negative. Force 2, that reactive force, that's 0 in the I direction and R in the J direction only. And then force 3 is the one that's a little bit trickier because it's at the angle to the I direction. So we need to work that out in its I and J. The way I look at it, thinking about here, we've got this is our I direction, or our x-axis runs up the plane. So we need this angle here. Now our angle's going to be 90 degrees plus 30, but it's coming down, if we think of this in the x direction, that's going to be negative 120. So over here, we write it as just 5g cos negative 120. It's I plus 5g sine negative 120, j. It's the easiest way to resolve into both our x and y directions. Now, of course, we can get, I'm going to do this as much as I can tech-free, cos negative 120. Now I'm going to use my triangle, and of course, knowing negative 120 is in this quadrant, cast, it's tan, so both the cos and the sine will be negative. So this will be negative 5g, and of course, if this is negative 120, this is 60. What is the cos of 60? It's a half I. This will be negative 5g, and what is the sine of 60? It is root 3 on 2. So I'm just going to write that a little bit neater. Negative 5g on 2i, and negative 5 root 3 2g is my j. So to find acceleration and r, let's do acceleration first. We're going to talk about in the I direction. What's happening parallel to the plane? Now let's just look, what forces do we have? We've got 15 newtons, or 15 I, 0 and negative 5g on 2. Now, of course, force is mass times acceleration. Our mass is 5. So it stays the same. So force is mass times acceleration. And mass is 5. Divide through by 5. It's 3 minus g on 2. Of course, that's going to be, in your calculator, 3 take 9.8 on 2. A is going to equal negative 1.9. Now, acceleration, the negative indicates that acceleration is happening down the plane. That's what the negative means. So I'll write that the acceleration, is 1.9 meters per second squared, because that's my units, down the plane. All right, so that's my magnitude, 1.9 meters per second squared. That negative indicates that it's down the plane. So I can tick off, I have found acceleration. Now I need to find R. So I'm going to look in the J direction, or perpendicular to the plane. And I look at my forces I listed out to start, and I'm looking in the J direction. The top force has 0 in the J direction, then it's R, then it's negative 5 root 3 on 2g. Now, in the J direction, there's no movement. Okay, we're going to write that, no movement. So if you think of your mass sitting here on the plane, it's moving down the plane, but there's no movement this way. There's no J movement. So that means this is equal to 0. So if we just rearrange, take one to the other side, R equals 5 root 3 on 2g, 5 root 3 on 2 times 9.8, which I don't know what that is. On your calculator, you can work out what that is. I don't have a calculator with me at the moment, and you can work out that's going to be so many newtons. Okay, that's example 31.